Greeting my data science friends. I wanted to make this quick video to take a look at the section 28.3.1 and fitting parabolas. So this is in the section that we're looking at of regression and fitting curves into regression, and specifically this local weighted regression. So one thing that's important to point out here, the difference between a regression line that fits all of the data points, which is the linear model or the standard regression that you learned about in statistics and we talked about before in this course. And this particular situation of the local weighted regression is that what we're doing, instead of looking at all of the data points, is we're saying, hey, look, there is a time series in the data points. So when we look at these polling numbers and polling results, the idea is that instead of looking at this as all one group of data, we're looking at it over time intervals. In this particular graph that you see here, the time interval is 21 time frames divided by the total number of days, right? So that's dividing up all the total number of days into these separate intervals. In the example that I want to look at, where we're comparing this polynomial degree 1 that we're fitting and a polynomial degree 2 that we're fitting. The time frame we're doing is 28 units divided by the total number of days. And the thing that I really want to point out here in the code that's important to note, when I take a look at R and I've run this code, and then we look at the graph zoomed in, I've made the data points blue, by the way, instead of the author made them gray. But we see that this red line is the fit 1, and that's degree 1, right? That is a linear approximation with a linear regression line and over each of these time intervals, right? So small little lines over each of these time intervals, and then it connects to the next one, then it connects to the next one, and so on and so forth. And all those degree 1 splines, is the fancy word for them, make this curve all the way across the data across our time series. The thing I want to point out is that the default in R for this linear regression technique, when we're looking at our LOESS for our locally weighted regression, the default is degree 2, so parabolas, right? And so when you look at the orange line in our code, that's this. So this is the orange line, which is the second one. And that, see, I didn't put degree equal. I left that blank because the default is degree of polynomial 2. But I could have typed degree equal 2, but I purposely didn't in this case to make that point. So then you see I have my orange, and I'm making it 1. And that's the orange is for the smooth 2. And the smooth 2 is for that degree 2, right? That's what we've written here. And the red, I have this as a dashed line, the type of line 2, L2y equals 2. And that is for smoothing 1. And smoothing 1 is the fitted one, right? So that's this one of degree 1. And then I make this nice graph. Another thing I wanted to point out is our author does actually make this point in the textbook, but I want to make the point again here. Sometimes it's often the case that people we're working with or working for sometimes can be older or just have visual impairments. But I can tell you, as we get older, it can be difficult to read things with small fonts and certain gray palette color scales. So anytime we can put more color or thicker color or bolder color, it can help us as data scientists present our data in a way that's clearer and crisper for our decision makers. I've actually had this experience where I worked for an older gentleman who had As we get older, we have trouble sometimes seeing small font, and he was towards the end of his career. And I really made him happy when I would make my lines bolder and um, the font bigger and things like that. So one of the things I want to try here is to do that always when we're doing our data. So let's take a look if I can make that happen here. And what I'm going to do is in the geom line where I'm putting my part where I have color red and then the line type equals 2, so that's the dashed. I'm going to put size equals, let's make it 2. And then I'm going to do the same thing for my orange line, and I'm going to make it size equals 2. And so when I do that, let's see if I get a thicker line that's easier to see for someone who might have some difficulty seeing. And this can be, as you can see here, this can be a big advantage over what we had before, especially when you're dealing with folks that have some visual impairments. And then also, if you're putting this up on a big projection screen where people are trying to read it as it's being, several people you're presenting to in the room, or the decision maker has had this, you prepare this presentation and they're showing it to a group of people in the room. And having those crisper, bolder lines can be a great tool for you to have and for your decision makers to have.